1.1 is calculating molar mass. The materials needed for this video are a periodic table and a scientific calculator. If you do not have a scientific calculator, you can open a tab to Google and Google scientific calculator, and there's one on the screen provided for you. So we talk about atomic mass as the mass of an atom. An atomic mass can be found on the periodic table. And if you take a look at the periodic table, it is usually the number that is going to be found on the bottom of your periodic table. And that's what we refer to as the atomic mass. It is the average mass of an atom for that particular element. The units of atomic mass are going to be in AMU. But in chemistry, we can also find the mass of a compound. And the mass of a compound can be found by adding up all the pieces of the compound. Sometimes you're going to run into different names for mass of a compound. You will run into molecular mass when it's talking about the mass of a covalent compound. Units for molecular mass are going to be in AMU. We'll talk about formula mass if we're talking about an ionic compound. Again, we just add up the pieces and its units are going to be in AMU. But the one we're interested in for this unit and for this trimester are going to be molar mass, which is really the mass of anything. Molar mass is defined as the mass of 1 mole of an atom or a compound. It is the exact same number as what you find for atomic mass, for molecular mass, for formula mass, except for its units are different. And these units are going to be really important because these are going to be the units that we are going to be using. Its units are going to be grams per mole. So let's take a look at the process of finding the molar mass. And again, you're going to need a calculator and you're going to need a periodic table. So when I take a look at a chemical formula, I'm going to see 2 little subscripts in this formula. And those subscripts tell me the number of each atom in that formula. So when I see that it is N2, it means that for nitrogen, I have 2 pieces of nitrogen. And when I see that it's O5, it means that I have 5 pieces of oxygen. In the compound. If I go to my periodic table and I find nitrogen and oxygen, nitrogen has a molar mass of 14.01 and oxygen has a mass of 16.00. Well, if I have a compound that's made up of 2 pieces of nitrogen, each piece of nitrogen then has a mass of 14.01. And each piece of oxygen has a mass of 16.00. So if I want to find the mass of the compound, I'm going to take 2 times the 14.01 to get the mass of nitrogen. And if I punch that into my calculator, I'm going to come out with 28.02. And if I punch this into my calculator, I'm going to have 5 times 16. Oops, put an equal sign here. And 5 times 16 is going to come up to be 90. So if I want the mass of the compound, what do I need to do? Well, I need to add these 2 pieces together. So I've got 0.02 and an 8, and I'm going to come up with 108.02. Now, most important thing about chemistry is based off of units. And the units to go along with this number are going to be the units for molar mass and they're going to be grams per mole. Now, if I take a look at NaCl, NaCl is an ionic compound that is going to be made up of one piece of sodium and one piece of chlorine. And I can go down to my periodic table and I can find my mass of sodium. My mass of sodium is going to be 22.99. And I can find my mass of chlorine, and my mass of chlorine is going to be 35.45. And I am going to take that one piece of sodium times its mass of 22.99. And I can take that one piece of chlorine times its mass of 35.45. And really, in my calculator, this doesn't have to be a separate problem. I can just take 1 times 22.99 and 1 times 35.45. And my mass of sodium chloride is going to come out to be 58.44. And again, its units are going to be grams per mole. Now, when I take a look at calcium phosphate down here, calcium phosphate looks a little bit different because it has a polyatomic that are found in parentheses. Remember, a polyatomic is just a chunk, phosphorus and oxygen, that is always stuck together. So that when I see parentheses and a number outside of parentheses, it works very much like distributive properties in math. It means that I literally have not one piece of PO4, I have two pieces of PO4. So that if I'm trying to figure out the number of each atom to figure out the mass, well, calcium's got a 3 by it, and there's 3 pieces of calcium. But phosphorus is 2 times the phosphorus and 2 times the oxygen, or I have 2 pieces of phosphorus, and I have 2 times the oxygen, so 2 times 4 is 8, or 4 plus 4 is 8. Now we already found the mass of oxygen up here to be 16. So let's check out the mass of phosphorus and the mass of calcium on my periodic table. So calcium has a mass of 40.08, and phosphorus has a mass of 30.97. And I can do this as one calculation. I don't have to separate this out in my calculator. I can take 3 times 40.08 plus 2 times 30.97 plus 8 times 16 and as I punch those numbers into my calculator, 2 times 30.97 plus 8 times 16.00 before I hit equals, and my calculator is going to come out with 310.18, and the most important part of this is going to be grams per mole. Now you should find a practice sheet with some practice problems in the Google folder. Why don't you take a look at those and see what you can do with this. Have a great day, guys.